how to integrate integral x squared over x times sin x positive cos x raised to the power of 2 times dx. This is a very hard integral to actually integrate. So having mentioned that, let me show you a technique to integrate this. So foremost, what I wish to do is I would like to start off with the all important word called consider. So this is the integral I'm going to consider. I'm going to be rewriting this as integral x. I'm going to take 1x and I'm going to multiply it with cos x. I know what you're thinking. How do I do that? Since I multiplied this with cos x, I need to also multiply the denominator with cos x. So there's going to be a cos x that's going to be coming. But foremost, let me write this in this fashion. X times cos x over x times sin x positive cos x raised to the power of 2. The only addition here is cos x. So I'm going to group this as a term. I know I have an additional x because the numerator has got x squared. I've just taken 1x, so the next x has to be there. So I'm going to divide this x by this cos x. So this is how I have written. And then the differential operator dx. So I have multiplied the numerator by cos x and the denominator by cos x. So I actually haven't changed anything else. Now what I wish to do is I would like to apply integration by parts formula. Now from integration by parts, I know that the formula is uv negative integral v du. So this is going to be u dv. Integral u dv is equal to uv negative integral v du. This is the formula. So I need to take my u and I need to take my v. In fact, in this case, I need to take my dv. So my u is going to be x over cos x. Now you need to choose your u properly. If you don't choose your u properly, you wouldn't be able to integrate this. So you need to have a little bit of creativity and little bit of futuristic visualization. Having mentioned that, my dv is going to be whatever term that you have here, x times cos x over x times sin x positive cos x, right? So this is going to be my dv. In fact, since the degree is 2, I need to place the 2 there. And I got the differential operator. I am also taking the differential operator. So that is the complete assignment of u and dv. Now we need to differentiate this quantity, right? So I would be utilizing u over v. This is called as a quotient formula. So d of u over v is nothing but v times u dash minus u times v dash divided by v squared. This is a formula. So therefore, if you were to differentiate this, this is going to be cos x times differential of x, that's going to be 1, negative x times differential of cos x, that's going to be negative sin x, divided by cos x raised to the power of 2, that's going to be cos squared x. I can rewrite this as cos x negative negative positive is going to be positive x times sin x divided by cos squared x. This is going to be my du. Now let me integrate this quantity. Integral dv is going to give me v. That's fine, but we need to integrate this part, right? So for that, let me just take t to be equal to x times sin x positive cos x. So if I were to find this dt, differential of x into sin x, that's going to be product rule. So x times differential of sin x, that's going to be cos x, positive sin x times differential of x is going to be 1, times dx will be coming there, but there is another term, so we need to differentiate that term also. So differential of sin x, differential of cos x is going to be negative sin x. This entire quantity is multiplied with dx. Now if you were to rewrite this, this is going to be x times cos x, positive sin x, negative sin x times dx. So positive sin x, negative sin x gets cancelled, giving me x times cos x times dx. What you got on the left hand side? This is dt. So that is a nice representation. Now I need to take dt and I should say I need to substitute dt in place of x times cos x dx, right? So if you were to see this, you got x times cos x dx, so you can substitute it over there. Now I need some space, so I'm utilizing this part. So my integral dv is going to be v, this is equal to x times cos x dx, x times cos x dx, this is going to be dt, divided by x sin x plus cos x, that's going to be t. This has got a degree 2, so raise it to the power of 2. You push it to the numerator, this is going to be t raised to the power of negative 2 times dt. This is going to be t raised to the power of negative 2 positive 1 divided by negative 2 positive 1, which is equal to t raised to the power of negative 1 divided by negative 1, which can be rewritten as 1 over t with a negative sign, which is equal to negative 1 over, my t is x times sin x positive cos x. And what is my, or I should ask, what's the quantity on the left hand side? The quantity is v. So this is my v, right? So we got a v, we got the u, we got du, and all we need to do is to substitute it here. So if you were to take this as sum 3, therefore my 3 can be rewritten as, this is equal to u, what is my u? X over cos x, substitute that, x over cos x. My v is what? Negative, so I place the negative sign here, 1 over x times sin x positive cos x. So this is uv, negative v du. So where is my v? My v is this quantity, so negative negative positive, 1 over x times sin x positive cos x times my du. My du is what? What's my du? So this is going to be my du, right? So apparently I need to place dx there. So because you differentiate all this, you need to also place the differential operator dx. So differential operator is placed there. So let me place this du. So du is nothing but cos x positive x times sin x, x times sin x times the dx over cos squared x, right? Now x times sin x positive cos x, x times sin x positive cos x, they can be cancelled. So this is equal to negative x over cos x. Now what is 1 over cos x? 1 over cos x is nothing but secant x. So you can substitute that. So x times secant x divided by x times sin x positive cos x, positive 1 over cos x is secant x, so 1 over cos squared x is nothing but secant squared x times dx. Now what is the integral of secant squared x? Can you guess? Now let me show you that. Suppose you got y is equal to tan x and you want to differentiate this dy over dx. So what is the differentiation of tan x? The differentiation of tan x is secant squared x. Now to get the original function back, what do you have to do? You got to integrate this. So integral of secant squared x will give you the differential, or I should say the original function, right? So differentiation and integration are reverse operations. So integral of secant squared x is what? Tan x. So this is equal to negative x times secant x divided by x times sin x positive cos x positive tan x positive arbitrary constancy. So this is the final solution for this beautiful question, and I'm sure if you don't adopt this technique, solving this question is close to being impossible. Thank you everybody.